Here is the outline for question 7. We are given u equals -2 plus I, and v equals 3 plus I. Part 1a, find u plus v. Part 1b, find u over v with full working. Part 2, state the argument of u over v. Part 3, prove angle AOB equals 3 pi over 4. Part 4, describe the geometric relationship between OA and BC. Let's start with Part 1a. Part 1a, find u plus v in the form x plus iy. Adding complex numbers, add real parts and imaginary parts separately. Write u plus v. Substitute u and v. Add real parts and imaginary parts separately. Final answer, 1 plus 2i. Real part, -2 plus 3 equals 1. Imaginary part, 1 plus 1 equals 2. Next, Part 1b, divide u by v. Part 1b, find u over v in the form x plus iy. We'll show every step. To divide complex numbers, multiply top and bottom by the conjugate of the denominator. The conjugate of 3 plus I is 3 minus I. This makes the denominator real. Write u over v as -2 plus I, over 3 plus I. Multiply by 3 minus I over 3 minus I, which equals 1, so the value is unchanged. Expand the numerator using FOIL. First, -6. Outer, plus 2i inner, plus 3i. Last, minus I squared, which is plus 1. Remember, I squared equals -1, so minus I squared equals plus 1. Collect the numerator, -5 plus 5i. Now expand the denominator. Move earlier work up. Use difference of two squares, 3 plus I times 3 minus I equals 10. Combine numerator and denominator. U over v equals -5 plus 5i, all over 10. Split and simplify to -1/2 plus 1/2 I. On the diagram, u over v is the point -1/2, plus 1/2 I. So u over v equals -1/2 plus 1/2 I. Part 2. Find the argument of u over v. Part 2. State the argument of u over v, which is -1/2 plus 1/2 I. Real part is negative, imaginary part is positive, so we're in the second quadrant. Argument equals pi minus the reference angle alpha. Reference angle alpha from the triangle. So alpha equals pi over 4. Second quadrant, argument equals pi minus alpha. Final argument, 3 pi over 4. So the argument of u over v is 3 pi over 4. Part 3. Prove that angle AOB equals 3 pi over 4. Part 3. Prove that angle AOB equals 3 pi over 4, where O is the origin, A is u, and B is v. Key theorem, angle AOB equals the modulus of arg u minus arg v, which equals the modulus of arg u over v. Angle at the origin equals the difference of arguments. Same as the argument of u over v. From part 2, argument of u over v is 3 pi over 4. Therefore angle AOB equals 3 pi over 4. Verify, arg u minus arg v also gives 3 pi over 4. Part 4. The Argand diagram and the geometric relationship. Part 4. On the Argand diagram, state the geometric relationship between OA and BC. Draw the Argand plane on the right. Mark O at the origin, A at u equals -2 plus I, B at v equals 3 plus I, and C at u plus v equals 1 plus 2i. Draw the parallelogram, O to B and O to A, then A to C and B to C. Shade the parallelogram OABC. Mark angle AOB as 3 pi over 4 at the origin. Tick marks on OA and BC show they are parallel and equal in length. OABC is a parallelogram. OA represents vector u, and BC also represents vector u, from V to V plus u. So OA and BC are parallel and equal in length. The geometric relationship, OA is parallel to BC, and they have equal length. Here is the full summary. Full summary. Part 1a, u plus v equals 1 plus 2i. Part 1b, u over v equals minus 1/2 plus 1/2 I. Part 2, argument 3 pi over 4. Part 3, angle AOB equals 3 pi over 4. Part 4, OA parallel to BC with equal length, a parallelogram. That completes question 7.